Hey guys, we are moving on to lesson 6-5 and we're going to be talking about algebra properties. So properties are things that allow us to do certain things in math, and that's always going to be true. So today's date is 2/5/20, and so we're going to start with, let's just say, algebra properties. And let's start with our first one. The first one is called the commutative property. Not commutative, commutative property. Now, commutative property sounds like the word commute, and commute is what somebody does from, let's say, work to, or from home to their work, and then from work to their home. And the interesting thing is, when I drive from my house to school, I take a certain route. And when I come home, I basically do the same route, but in the reverse order. So that's really what commutative property does. It says that changing order, I'm going to box that guy in red because he's very important. Changing order does not change the answer. Now, in order for the commutative property to be always true, I have to look into what properties might it work. So, of all the properties we talk about, all of them they work for multiplication and for addition. Okay, now some of them work for subtraction and division, and some of them do not. So let's talk about the commutative property of addition. I'm going to abbreviate property to prop of addition. So how does the definition change now that I've put in addition? Well, what it says is the order you add two numbers does not have or make a difference in the answer. Okay, so an example of that would be, I have 7 plus 9, and that would be exactly the same answer as 9 plus 7. So 7 plus 9 is 16, 9 plus 7 is 16, and they are going to be equal to each other. Okay? Now, commutative property also works for multiplication. Oops, perhaps if I spelled it correctly, right? Commutative. Again, I'm going to abbreviate property to prop of multiplication. Now, when you are identifying properties in the practice that we'll do tomorrow, you can't just say commutative property. You have to determine which of the commutative properties, the one of addition or the one of multiplication. So it says the order you multiply two numbers does not make a difference in the answer. Okay, and so I'll give you an example of that. What I get when I multiply 4 times 3 is exactly the same answer I get when I multiply 3 times 4. So I get 12 equals 12, and so that's true, just like that guy was true. So what's beautiful about this commutative property of multiplication is when you started learning your multiplication facts, you all of a sudden, when you understood this idea, you didn't have to memorize two separate multiplication facts. If you know 4 times 3 is 12, then you automatically knew that 3 times 4 is 12. And the same thing with your addition facts. Okay, so that's a commutative property. Now, we're going to go through 3 different properties and a definition, and it should all fit on your first page. Now, I want to keep all the properties together, so that's why I'm going to go to the next screen. So this is still my first page, and I'm just maybe a quarter of the way down on my page. All right, so the next property I want to talk about is the associative property. Okay, so the associative property, if you think about it, your associates are the people that you hang out with. My associates are my colleagues, the teachers that I pal around with. Okay, so the associative property is talking about a group. All right, so associative property is very unique. Okay, it deals with, I'll put it here, 3 numbers and the same operation. So we're going to be working with adding, subtracting, multiplying, dividing, our operations. And so this says we have 3 numbers and we're all adding, or we're 3 numbers and we're all multiplying. Again, you might have to test out to see if subtraction and division work for associative property. But let's get back to that definition here. And the associative property says changing the group, put that in red, very important again, changing the group of numbers does not change the answer. So here's what happens. Believe it or not, you cannot add or multiply 3 numbers simultaneously. What you can do is combine 2 numbers and then quickly add on or multiply the 3rd number. Okay? I know some of you will think, no, that's not true. I can do it all at one time. Well, no, your brain just works really fast. Okay? So you have to make a decision which 2 numbers you're going to add or which 2 numbers you're going to multiply, because those are the 2 properties we're going to talk about. Okay? So let's talk about the associative property of addition. Oops. Got to spell that better. Oh, and I got a dot. Associative property, and again, abbreviate property of addition. And it basically says you can add any 2 numbers, then add the 3rd number, and the answer will always be the same. Okay, so let me give you an example of that. So let's do the quantity 2 plus 3 plus 4. According to the associative property, I'm going to get exactly the same answer as 2 plus the quantity 3 plus 4. So notice here, order stays the same. So we're not switching the order of the numbers, we're just switching who gets the parentheses. So let's prove it out. 2 plus 3 is 5, and that leaves me with plus 4. And then we have 2, and 3 plus 4 is 7. 5 plus 4 is 9. 2 plus 7 is 9. So we just proved out the associative property of addition works. Okay? Let's talk about the associative property of multiplication. Again, I'm going to abbreviate prop. Okay, and it says, oh, you know what? I just looked back there. It says you can any. You can add any two numbers. Then add the third number, and the answer will always be the same. So for this one is you can multiply any two numbers, any two numbers, then multiply by the third number. So again, we only have three numbers in these. And the answer will be the same. Okay, so let's do an example of that. So we have the quantity 3 times 5, that times 2, and according to this property, I would get the same exact answer if I have 3 times the quantity, 5 times 2. So again, order of operations, forgot to mention that before, we are dictated to do what's in the grouping symbol first. So on the left side, 3 times 5 is 15, and then it's times 2. Over on the right side, 5 times 2 is 10, so we have 3 times 10. 15 times 2 is 30, 3 times 10 is 30, and we just proved that the associative property works for multiplication. All right, next property. I'm going to go to the next screen. I still should be on the same page. If you guys need to go on to another page, I have no problem. Our examples that we're going to practice, not that big of a deal. All right, so let's go with our third property, which is the identity properties. And this basically says, when doing math with certain numbers, the answer is what you started with. Now that sounds really vague, but you'll see in the examples. Okay, so let's get into it. Let's dig into it and see what I'm talking about. So first thing we're going to do is talk about the identity property of addition. So again, it may work for subtraction and division. You're going to have to look into it, but we only are going to look at the associative property, or the identity property of addition and the identity property of multiplication. Okay, so can you think of a number that you can add to a number and you get what you started with? So for example, 5 plus what equals 5? Oh, 0. So the identity property of addition says this. Adding 0 to any number. So I'm going to put a red box because that's going to be important. And adding 0 to any number results in the given number. In other words, the number doesn't change. The given number. My brain. Whew. Okay, so let's put that guy in there that we talked about. 5 plus 0 equals 5. Okay, so adding 0 to any number results in the given number. Alright, so if that's true, let's explore the identity property of multiplication. So now I want you to think about what number could you multiply another number by and get the number you started with. I think I'm hearing you guys, and you're right. Multiplying by 1 results in the given number. So I'm going to box up that multiplying by 1. Okay, so for example, if I have 7 and I multiply it by 1, I end up with 7. So think about identity. It's who you are. You're not going to change. So even though I multiply by 1, I didn't change. Even though I added 0, I didn't change. Okay? So again, these properties are always going to be true for any kind of number. So that's the whole bottom line about properties. And you're going to continue to study properties throughout your math career, a big time in geometry. Man, yeah, algebra, without it, what could we do? So statements, that's what a property is, that are true for any number. Okay? All right, so then I have one last word for us, and we've used this idea equivalent before, equal value. So equivalent expressions, so expressions are written versions of English turned into math. So these are going to be, again, equal value is how we translate equivalent. So these are two expressions. They could be numerical or they could be algebraic. Two expressions that have the same value. Okay, so what I'm talking about is when I was doing my examples, let's say with the commutative property, 6 times 10 is going to give me 60, just like 10 times 6 is going to give me 60. So we call 6 times 10 and 10 times 6, those are equivalent, I could write it, equivalent expressions. They have the same value. In this particular example, they both equaled 60. Okay? All right, so I'm going to go now to my second page. If you're already on it, so be it. Just remember to title that second page, Lesson 6-5, Algebra Properties. Today's date is going to be 2/5/20. Okay, so I'm going to write the directions. So what I'm going to do is pause it, write it, unpause it, and boom, they're going to show up. So then I suggest you also pause it and write it, okay? Okay, so our directions say determine whether two expressions are equivalent. If so, tell which property is applied. Be specific. That means tell me if it's a property of addition or a property of multiplication. If not, explain why. All right, so first example. We have 15 plus the quantity 5 plus 8, and we have the quantity 15 plus 5 plus 8. So some of the things I do is I kind of look at which property it might fall into. So first I notice same three numbers, same operation, or I should say same operations. Okay, so what we talked about is what had three numbers? Oh yeah, that's the associative property. So we are going to check if it's actually the associative property. So what we're going to do is solve each of those expressions and see what we come up with. So I'm going to write them again. Over here we got 15 plus the quantity 5 plus 8. And we're going to leave it blank because we don't know if it's true. And then we have 15 plus 5 plus 8. And the other thing, the order did not change. Okay? 15, 5, 8, 15, 5, 8. So let's go ahead and solve away. So 15, we have to just write him, but because we have to start with what's in the grouping symbol, and we get a 13. And then 15 plus 13 is 28. Now over here, we start with the grouping symbol, and we have 15 plus 5 is 20, and then we have plus 8. So far, the numbers don't look like they're the same, but when I add 20 and 8, I get it. So what that tells me is yes, those guys are equivalent. So that allows me to conclude that this is the associative property of addition, because it was the addition symbol that was being used. Okay, let's do one more. I wrote pretty big that time, didn't I? So this one says 20 take away 12 minus 3, and 20 take away 12 minus 3. So in the first one, the parentheses was around the 20 minus 12. In the second one, parentheses were around the 12 minus 3. So what do I notice? I've got the same exact three numbers in the same exact order, same operations. Could it be associative property again? All right, let's test it out. So let's see, we get 20 take away 12 is 8. 8 take away 3 is 5. Okay, over here, we're going to have 20 and then minus, and then 12 take away 3 is 9, and 20 take away 9 is, what? That can't be 11. Oh my gosh, that is not true. So since the answers are not the same, this is not a property. Because remember, properties have to be always true. So what we can conclude from this is there is no associative property of subtraction. Voila, now we have an answer. All right, that's it. I'll see you tomorrow. We'll discuss this a little further. All right, bye now.